On a quiet summer night in 1977, a radio telescope picked up a signal so unusual that the astronomer studying it simply wrote one word in the margin. Wow, no one has ever heard it again. Here on Made for Sleep, we like to slow history down and sit with the questions that linger. Tonight we'll wander through the story of the WOW signal and humanity's long, patient search for ancient cosmic neighbours among the stars. Let the fire crackle softly beside you, and if you feel like it, drop a follow. Tell me how you're doing in the comments and what time it is where you're listening from. On an August night in 1977, a radio telescope in Ohio detected something unusual. A strong, narrow band signal from deep space that lasted exactly 72 seconds. One astronomer would scribble "Wow" in the margin of the printout, and that exclamation became the name for one of astronomy's most persistent mysteries. This is the story of that signal, the patient search for cosmic neighbours, and the quiet wonder that drives humanity to listen to the stars. The grass beneath you still holds the day's warmth, and the air smells of dust and distant water. Above you, the night sky spreads out like someone spilled milk across black stone, and you're doing what humans have done since they first looked up, trying to make sense of the lights. The stars don't twinkle the way poets will later claim. They pulse, steady and patient like distant fires that never need feeding. You've noticed that some of them move, wandering across the sky over weeks and months while others stay fixed in their positions. Your people have names for the wanderers, though you don't yet know their planets. You just know they behave differently, and different things demand attention. Your neighbour, an older person with better eyesight than yours, points out a pattern that looks like a hunter, or maybe a farmer, depending on who's telling the story. The thing about patterns is that once someone shows them to you, you can't unsee them. The stars suddenly arrange themselves into shapes, into stories, into something more than random points of light. You've turned chaos into order using nothing but imagination and the human need to find meaning in things. The moon rises, fat and orange, near the horizon, and you remember that it changes shape throughout the month. Nobody in your village can explain why. The best theory involves a celestial creature that slowly eats the moon, and then, for reasons unknown, spits it back out again piece by piece. You have doubts about this explanation, but you don't have a better one, so you keep quiet. Sometimes keeping quiet is the smartest thing you can do. A star moves across the sky, except it's not a star. It's what your descendants will call a meteor, a piece of cosmic debris burning up in the atmosphere. To you, it's a sign, though, of what nobody can agree. Some say it means rain is coming. Others claim it portends death or birth or a good harvest. The thing about signs is they're flexible enough to mean whatever you need them to mean, which makes them either very useful or completely useless, depending on your perspective. You've spent enough nights like this to know the sky follows rules. The same stars appear in the same places at the same times of year. The sun rises and sets with predictable regularity. The moon waxes and wanes on a schedule you could set your calendar by, if you had a calendar. The universe operates according to patterns, and patterns suggest order, and order suggests something worth understanding. But the sky also contains mysteries that resist explanation. Sometimes the sun disappears in the middle of the day, stolen by a shadow that creeps across its face and then retreats. Sometimes the stars shoot across the heavens in great cascades that light up the night like a celebration. Sometimes strange lights appear in the northern sky, rippling curtains of colour that have no business being there. The universe gives you enough answers to encourage questions, but withholds enough information to keep you guessing. You fall asleep under those stars as humans have done for hundreds of thousands of years, and you dream about what might exist beyond them. Not because you're particularly imaginative, but because wondering about distant things seems to be built into human nature, like the ability to walk upright or tell stories. You don't know that people will still be wondering about those same questions thousands of years from now, armed with tools you couldn't imagine in your most fevered dreams. You just know the sky is beautiful and vast and utterly mysterious, and that seems like enough reason to keep looking at it. The meadow grows cold as the night deepens and you pull your rough blanket tighter. Above you, the stars continue their patient wheel across the heavens, indifferent to your questions, unconcerned with your theories, simply existing as they have for billions of years before you were born and will for billions of years after you're gone. Somehow, that doesn't make them less interesting. If anything, it makes them more so. You're standing in a field in New Jersey in 1932, which makes you roughly 5,000 years removed from that Mesopotamian meadow, and you're looking at something that would appear completely insane to that ancient skywatcher. It's an antenna, but not the kind that will eventually sprout from rooftops to catch television signals. This one looks like a strange metal skeleton, all angles and braces, designed to detect something invisible. Karl Jansky, the engineer who built this contraption, is trying to track down sources of static that interfere with radio telephone service. It's a practical problem with a practical purpose, which is how most scientific discoveries actually start, not with genius revelations under apple trees, but with someone trying to fix an annoying technical issue. The romantic version of science makes for better stories, but the mundane version is usually closer to the truth. The antenna rotates slowly on wheels from a junked Model T Ford, and Jansky has been listening to the hiss and crackle of radio noise for months. Most of it he can explain. Thunderstorms, local electrical equipment, the general electromagnetic chatter of modern civilization. But there's one source of noise that puzzles him. It appears and disappears with a regularity that doesn't match anything on Earth. At first, Jansky thinks it might be the sun. That would make sense. The sun is hot and turbulent and constantly spewing electromagnetic radiation. But the signal doesn't track with the sun's position. It appears 4 minutes earlier each day, which means it's following sidereal time, the time kept by the stars rather than the sun. Whatever is making this noise is coming from beyond the solar system. You watch Jansky make careful notes, his breath visible in the cold air. He's discovered something that nobody was looking for. Radio waves from the centre of the Milky Way galaxy. He doesn't know that's what they are yet. He just knows the signal is coming from the constellation Sagittarius, and doesn't seem to be human-made. The universe, it turns out, is noisy in frequencies humans can't hear without technological assistance. The scientific community reacts to Jansky's discovery with the enthusiasm typically reserved for someone announcing they've reorganised their sock drawer. A few people find it interesting, most ignore it. The problem is that Jansky's discovery doesn't seem useful, and science in the 1930s is very interested in useful things. Radio astronomy sounds like an oxymoron. Astronomy is about looking at things, not listening to them. The idea that you could study the cosmos through radio receivers seems backward and slightly absurd. But one person takes notice. Grote Reber, an amateur astronomer and radio engineer, builds a radio telescope in his backyard in Illinois. It's a parabolic dish 9 meters across, and his neighbours think he's lost his mind. The thing looks like a giant metal soup bowl, and Reber has constructed it in a suburb of Wheaton, where normal people plant gardens and mow lawns. Instead, Reber is trying to map radio emissions from space, which strikes his neighbours as the sort of thing that should be done elsewhere, possibly by someone else. You're standing in Reber's backyard now, in 1940, watching him make adjustments to his receiver as the stars wheel overhead. He's detected radio emissions from several cosmic sources, confirming and extending Jansky's work. The universe, Reber discovers, is broadcasting in frequencies across the radio spectrum. Galaxies, nebulae, the Sun and Jupiter all emit radio waves. The cosmos has been speaking in these frequencies for billions of years, but humans only just developed the ears to hear it. The work is slow and painstaking. Radio astronomy requires patience, careful calibration, and the willingness to spend long nights collecting data that might mean nothing. Reber fills notebooks with observations, creating the first radio maps of the sky. He publishes his findings in scientific journals, and slowly, very slowly, the astronomical community begins to pay attention. By the time World War II ends, radio astronomy has graduated from a backyard hobby to a legitimate field of scientific inquiry. The post-war years bring surplus military radio equipment and scientists looking for peacetime applications for wartime technology. Radio telescopes start appearing at universities and research institutions. They're strange-looking things, these dishes pointed at the sky, listening for whispers from the cosmos. Some are enormous, like the 250-foot dish at Jodrell Bank in England. Others are arrays of smaller antennas working together. All of them share the same purpose, catching electromagnetic radiation from objects too distant to visit and too faint to see. You're at Jodrell Bank in 1957 when the telescope detects signals from Sputnik, the first artificial satellite. The steady beep, beep, beep from the Soviet satellite is a reminder that humans are now adding their own radio voices to the cosmic conversation. The universe has been broadcasting for eons, but now Earth is broadcasting back, sending television shows, radio programs and radar signals out into space, whether anyone's listening or not. Radio astronomy reveals a universe stranger than anyone imagined. There are objects called quasars that blast out more energy than entire galaxies. There are pulsars, rapidly spinning neutron stars that sweep radio beams across space like cosmic lighthouses. There are clouds of gas between the stars that emit radio waves at specific frequencies. The radio universe doesn't look like the visible universe. It highlights different objects, different processes, different phenomena. It's like seeing the world through infrared goggles and discovering that heat reveals patterns invisible to normal vision. By the 1960s, radio telescopes have discovered so many strange things that one more mystery wouldn't seem particularly remarkable. The sky is full of beeps and hisses, static and signals, the electromagnetic chatter of a universe more active and energetic than the peaceful night sky suggests. Radio astronomy has transformed humanity's relationship with the cosmos, turning us from passive observers into active listeners. We're no longer just looking at the stars, we're eavesdropping on them. You're standing in a field in Delaware, Ohio in 1963, looking at what appears to be a football field-sized construction project that has nothing to do with football. It's the Ohio State University Radio Observatory, better known as the Big Ear, and it looks like someone tried to build a drive-in movie theatre screen and gave up halfway through. Two rectangular metal panels, each about the size of a building, sit parallel to each other, reflecting radio waves toward a central receiver. The Big Ear is a Krauss-type radio telescope, designed by John Krauss, a professor who believes in building things large and on budget. The telescope can't move like other radio telescopes. It's fixed in place, pointed permanently at the sky. Instead of moving the telescope to observe different objects, Krauss designed it to sit still and let the rotation of the Earth carry different parts of the sky through its field of view. It's an elegant solution to the problem of how to build a large telescope without spending money on expensive motors and tracking systems. You watch as engineers make final adjustments to the reflectors. The Big Ear will survey the entire sky visible from Ohio, mapping radio sources and cataloguing the electromagnetic landscape of the cosmos. It's methodical work, the kind of science that doesn't generate headlines but slowly builds a foundation of knowledge. The telescope will observe, record and catalogue, creating a comprehensive survey of the radio sky over years of patient observation. The way it works is simple, at least in principle. Radio waves from space strike one of the two reflectors, bounce to a second reflector, and then focus on a receiver positioned between them. The receiver sweeps through frequencies, listening to the radio voice of the cosmos in different channels. Every 72 seconds, as the Earth rotates, a new slice of sky passes through the telescope's beam. The Big Ear observes, records the signal strength, and moves on to the next patch of sky. By 1973, the Big Ear has completed its sky survey and begins a new project. The telescope will participate in SETI, the search for extraterrestrial intelligence. The idea is straightforward. If intelligent civilizations exist elsewhere in the galaxy, they might broadcast radio signals, either intentionally or as a byproduct of their technology. Earth, after all, has been inadvertently announcing its presence to the cosmos through television broadcasts, radio transmissions, and radar signals for decades. Other civilizations might do the same. You're in the control room now, watching as the SETI program begins. The telescope has been modified to simultaneously observe two frequencies, one at 1420 MHz, corresponding to the natural emission line of hydrogen, the most common element in the universe, and another nearby frequency. The logic is that any civilization trying to send an interstellar message might choose a frequency that other technological civilizations would naturally monitor. The hydrogen line is like a universal meeting place, a frequency that any radio astronomer anywhere would likely tune into. The search is automated. The big ear sweeps across the sky, and computers monitor the incoming signals for anything unusual. Most of what the telescope detects is noise, the hiss of cosmic background radiation, the crackle of distant galaxies, the electromagnetic whisper of gas clouds and stellar remnants. Occasionally, terrestrial interference shows up. Aircraft radar, satellites, CB radio operators. The computer is programmed to filter out these obvious sources of contamination. What constitutes an unusual signal? The computer looks for narrow band emissions, signals concentrated in a very specific frequency, like a radio station broadcasting on a single channel. Natural cosmic sources tend to produce broadband radio noise spread across many frequencies. A narrow band signal suggests a transmitter, something deliberately generating electromagnetic radiation at a chosen frequency. It's the difference between the white noise of a waterfall and a single pure note played on a flute. The search runs night after night, month after month, year after year. The big ear points at the sky, the Earth rotates, and the telescope listens. Most nights produce nothing interesting. The sky reveals its usual assortment of radio sources, all explainable by natural processes. No alien broadcasts interrupt the cosmic static. No messages emerge from the electromagnetic noise. The universe maintains its silence, at least in frequencies the big ear monitors. You watch the printouts accumulate, sheets of computer paper covered in numbers and letters representing signal intensity. Strong signals get higher numbers and letters, weak signals get lower ones. Most readings are in the ones and twos, representing typical background noise. The paper feeds out of the printer at a steady rate, creating a record of everything the big ear hears. Later, astronomers will review the printouts, looking for anything the computer might have missed. It's tedious work, this listening to the stars. There's no guarantee that anyone else is out there. Even if other civilizations exist, they might not broadcast in radio frequencies. They might have advanced beyond radio technology the way humans advance beyond smoke signals. They might exist but choose not to announce their presence. They might be too distant for their signals to reach Earth. Or their signals might have passed through the solar system millions of years before humans evolved. The search could be, in the most literal sense, a waste of time. But the big ear keeps listening anyway, because the only way to find out if anyone's broadcasting is to listen. And the only way to know listening is futile is to try it first. The telescope sits in its Ohio field, patient and unhurried, waiting for a signal that might never come. The stars wheel overhead, indifferent and silent, or so it seems. The universe keeps its secrets, if it has any, and the big ear keeps listening just in case. You're not at the big ear on August 15th, 1977, which is probably just as well because nothing obviously remarkable happens that night. The telescope operates automatically, as it always does, sweeping its unblinking electronic gaze across the sky while the Earth rotates beneath it. The night is warm, typical for August in Ohio, and the stars are out, though nobody at the observatory is looking at them. You don't need to see stars to listen to them. The big ear is pointed toward a region of space in the constellation Sagittarius, though pointed is a generous term for a telescope that can't actually move. The Earth's rotation carries different patches of sky through the telescope's beam, and tonight, as on every night, the telescope dutifully records what it hears. The computer monitors the incoming signals, printing out alphanumeric codes that represent the intensity of radio emissions at different frequencies. At 10:16 and 1/2 minutes PM, something unusual enters the big ear's field of view. The signal strength jumps dramatically. Where typical cosmic background noise registers as a 1 or 2 on the intensity scale, this signal climbs to a 6, then an E, then a U. The intensity keeps rising. Q, I, J, U. The alphanumeric code represents signal strength, with higher numbers and letters indicating stronger emissions. This signal is strong, much stronger than normal. The signal lasts exactly 72 seconds, which is precisely how long any object takes to pass through the big ear's beam as the Earth rotates. If the signal had lasted longer or shorter, it might have been dismissed as terrestrial interference. But 72 seconds suggest the source is astronomical, something out in space rather than a nearby radio transmitter. The signal appears at 1420 MHz, the hydrogen line, exactly where SETI researchers hope to find artificial transmissions. Then, as suddenly as it appeared, the signal stops. The intensity drops back to normal background levels. The cosmic static returns. The big ear continues its automated sweep across the sky, observing, recording, moving on to the next patch of celestial real estate. The telescope has no opinion about what just happened. It simply detected electromagnetic radiation, converted it to a digital format, and printed it out for later review. Nobody sees the signal that night. The big ear operates unattended, printing its continuous record of observations but requiring no human supervision. The data accumulates in boxes, waiting for someone to review it. This is how most astronomical observations work: automated detection followed by delayed human analysis. The universe doesn't wait for astronomers to be present before doing interesting things, so telescopes run around the clock, collecting data whether anyone's watching or not. Days pass. The printouts sit in their boxes, patient and unremarkable. The big ear continues its survey, listening to the same patches of sky every day as the Earth's rotation carries them through the telescope's beam. If the signal appears again, the telescope will detect it. If it doesn't appear, the telescope will record that absence just as faithfully as it recorded the presence. You're there when Jerry Eman, a volunteer astronomer, sits down to review the data several days later. He's going through the printouts the way he always does, scanning columns of numbers and letters, looking for anything anomalous. Most of the printout shows expected values, 1s, 2s, occasional 3s, when something slightly brighter passes through the field of view. The work is monotonous, which is probably why the unusual sequence catches his eye immediately. The numbers and letters are circled before Eamon consciously decides to circle them. His hand moves automatically, drawing a red pen around the sequence. 6EQUJ5. His brain is still processing what his eyes have seen. The signal strength peaked at U, one of the highest values the computer can print. The sequence shows a signal that rose, peaked and fell in exactly the pattern you'd expect from a point source passing through the telescope's beam. Eamon writes a single word in the margin next to the circled sequence. Wow! It's not a technical term. It's not a carefully considered scientific annotation. It's an exclamation of surprise, the kind of thing you write when you're startled by something unexpected. The word is hastily scribbled, the handwriting quick and rough. Later, that single exclamation will become the signal's name, because sometimes the simplest descriptions are the ones that stick. He checks the frequency. 1420 MHz, right on the hydrogen line. He checks the duration. 72 seconds, consistent with a cosmic source. He checks the intensity. Far stronger than typical background noise, stronger than most astronomical radio sources. Everything about the signal fits the profile of what SETI researchers hope to find. Narrow band, strong, located on a meaningful frequency, and apparently coming from space rather than Earth. You watch Eamon gather his thoughts, trying to figure out what he's looking at. The signal could be a glitch. Computers make mistakes. Equipment malfunctions. Cosmic rays can corrupt data. It could be terrestrial interference that somehow mimicked the characteristics of an astronomical source. It could be a natural cosmic phenomenon, something emitting narrow-band radio waves for reasons nobody understands. Or it could be exactly what it appears to be, a transmission from somewhere else. The problem with extraordinary claims is they require extraordinary evidence, and one signal, no matter how compelling, isn't extraordinary evidence. It's suggestive evidence, interesting evidence, the kind of evidence that makes you pay attention and start asking questions. But it's not proof of anything except that the big ear detected something unusual on one August night. Everything else is interpretation, speculation, and hypothesis. You're back at the big ear the following night, watching as the telescope points toward the same region of sky where the signal appeared. This is the obvious next step. Look for the signal again. If it was a genuine transmission from an extraterrestrial source, it might repeat. Civilizations broadcasting to the cosmos would presumably send their messages multiple times, knowing that any receiver might not be listening during the first transmission. The Earth rotates, carrying that patch of sky through the telescope's beam. The big ear listens, recording signal strength at 1420 MHz. You watch the printout emerging from the computer, hoping to see another sequence of high-value codes indicating a strong narrow-band signal. The paper feeds out slowly, numbers and letters marching across the page in orderly columns. The signal doesn't repeat. The printout shows ordinary cosmic background noise, the same unremarkable hiss that fills most of the telescope's observations. Whatever produced the wow, signal on August 15th has either stopped broadcasting or has moved on to a different frequency, or has pointed its transmission in a different direction, or it was never a transmission at all. Just some anomalous event that happened once and will never happen again. The big ear returns to that same spot in the sky every day for months, and every day the telescope records nothing unusual. The silence is frustrating, but not particularly surprising. Even if the signal was artificial, there's no reason to expect it would broadcast continuously, or even regularly. Earth's own radio transmissions are episodic and directional. We don't broadcast continuously in all directions. An alien civilization might be similarly selective about when and where it broadcasts. You're in the office where astronomers debate what the wow signal might have been. Some argue it was likely a comet, though comets aren't known to produce narrowband radio emissions. Others suggest it might have been a previously unknown type of astronomical phenomenon, something that produces radio bursts at specific frequencies under specific conditions. Still others maintain it could have been interference from Earth-based sources, despite the signal's characteristics suggesting otherwise. The debate is good-natured but ultimately inconclusive. Without repetition, without additional data, the wow signal remains an anomaly. A single data point looking for context. Scientists are uncomfortable with single data points. Science prefers patterns, repetitions, multiple observations that confirm or refute a hypothesis. One observation is a curiosity. 2 observations suggest a pattern. 3 or more observations become data you can work with. Over the following years, other radio telescopes point toward the coordinates where the big ear detected the signal. They listen at 1420 MHz, hoping to catch a repeat performance. The Very Large Array in New Mexico, a collection of radio dishes that work together as a single telescope, observes the region multiple times. The Arecibo Observatory in Puerto Rico, the largest single-dish radio telescope in the world at the time, adds its considerable sensitivity to the search. Nothing repeats. The sky at those coordinates reveals ordinary astronomical objects, stars, galaxies, clouds of interstellar gas, all producing the expected amounts of radio noise at expected frequencies. The region isn't special or unusual. There's no obvious source for a strong narrow-band signal. Whatever the big ear detected appears to have been a one-time event, or at least an event that hasn't repeated during times when telescopes were listening. You're watching as newer, more sensitive telescopes continue the search decades later. In 2012, the Arecibo Observatory conducts another targeted search of the WOW signal region. In 2017, researchers used the Allen Telescope Array, specifically designed for SETI work, to observe the same coordinates. In 2020, other radio telescopes joined the effort. All report the same result: no unusual signals detected. The absence of repetition doesn't disprove the signal's significance, but it doesn't help either. Science advances through replication. You observe something, then observe it again under controlled conditions, then invite other scientists to observe it using their own equipment. Phenomena that can't be replicated become increasingly suspect. Either they're artifacts of faulty equipment or measurement errors, or they're genuine events that occur so rarely that catching them requires extraordinary luck. The WOW. Signal falls into this uncomfortable category of observations that can't be confirmed or denied. It's there in the data, a real detection recorded by a real telescope. The signal has characteristics consistent with an artificial origin, but also characteristics that could have natural explanations. It appeared once and never repeated, or at least hasn't repeated during the thousands of hours telescopes have spent searching for it. You watch astronomers add the WOW signal to the growing list of unexplained astronomical observations, not because they want to give up trying to explain it, but because sometimes the honest answer is we don't know. Science has a category for mysteries that resist solution, phenomena that remain ambiguous despite investigation. These aren't failures so much as reminders that the universe is under no obligation to make itself easily understood. The big ear keeps listening, night after night, year after year, waiting for another signal that might clarify or contextualize the first. The telescope surveys the sky with mechanical patience, indifferent to the excitement or disappointment of the humans analysing its data. The stars continue their nightly parade across the heavens, silent as always, or at least silent in the frequencies humans are listening to. You're sitting in an office in 2017, 40 years after the WOW signal, watching Antonio Paris present a hypothesis. Paris, an astronomer and professor, believes he's identified the source of the famous signal: comets. Specifically, two comets that were in the same region of sky on August 15, 1977, though nobody knew they were there at the time because they hadn't been discovered yet. The comets in question are 266P/Christensen and P/2008Y2, both discovered decades after the WOW signal. Paris argues that comets can emit hydrogen at 1420 MHz, the same frequency where the Big Ear detected its mysterious signal. Comets are essentially dirty snowballs, ice, rock, and frozen gases held together by gravity. When comets approach the sun, they warm up, releasing gas in a process called outgassing. That gas includes hydrogen, which could theoretically produce emissions at the hydrogen line frequency. The hypothesis is appealing because it provides a natural explanation that doesn't require invoking extraterrestrial intelligence. One of the principles of scientific investigation is that you should prefer simpler explanations over more complex ones, all else being equal. A comet is simpler than an alien civilization. If a comet can explain the data, then invoking aliens becomes unnecessary, like explaining your missing car keys by hypothesizing a conspiracy when you simply left them in the bathroom. You watch as other astronomers examine Paris's hypothesis with the skepticism that good science requires. The problem with the comet explanation is that comets aren't known to produce strong, narrow-band radio emissions at 1420 MHz. Paris's observations of the two comets show some hydrogen emissions, but they're much weaker than what the Big Ear detected during the WOW signal event. Scaling up those weak emissions to match the strong signal requires assumptions about comet behaviour that aren't well supported by other observations. Additionally, the WOW signal was extremely narrow band, concentrated in a frequency range less than 10 kHz wide. Natural sources typically produce broader emissions spread across larger frequency ranges. Narrow band signals suggest something acting like a radio transmitter, concentrating energy into a specific channel rather than broadcasting across the spectrum. While it's possible for natural processes to produce narrow-band emissions, it's unusual enough to require a good explanation. The debate over the comet hypothesis reveals how difficult it is to definitively explain a signal that appeared once, 40 years ago, detected by a telescope that no longer exists. The Big Ear was demolished in 1998 to make room for a golf course expansion, which is either pragmatic land use or scientific vandalism depending on your perspective. Without the original telescope, nobody can re-observe the signal using the same instrument under the same conditions. You're in a different office now, listening to other researchers propose alternative explanations. Some suggest the signal could have been terrestrial interference, a passing aircraft, a satellite, or ground-based radio transmitter that briefly produced a signal mimicking an astronomical source. The problem with this explanation is that the signal's characteristics don't quite match known sources of interference. It rose and fell smoothly over 72 seconds, following the pattern expected from a point source transiting the telescope's beam. Others propose more exotic natural phenomena. Perhaps it was a brief, intense emission from a previously unknown type of stellar object. The universe contains plenty of things that emit radio waves in unexpected ways. Pulsars, magnetars, flare stars, radio galaxies, quasars, maybe the WOW signal was one of these known phenomena behaving in an unusual way, or an unknown phenomenon that hasn't been observed before or since. The challenge with evaluating these explanations is that you're trying to reconstruct a 72-second event from 40 plus years ago using limited data. The Big Ear recorded signal strength at one frequency, from one location, at one moment in time. There's no spectrum showing how the signal behaved across multiple frequencies. There's no polarization data indicating how the radio waves were oriented. There are no simultaneous observations from other telescopes confirming the detection. You watch as astronomers do what scientists always do when data is insufficient. They gather more data. Telescopes continue observing the region where the signal appeared, hoping for a repeat performance. Researchers study comets more carefully, measuring their radio emissions to determine whether they could plausibly produce signals like the WOW signal. Others examine archives of old astronomical data, looking for similar events that might have gone unnoticed. What emerges from all this investigation is not a definitive answer, but a better understanding of the question. The WOW signal might have been a comet, though the evidence for that explanation has significant weaknesses. It might have been interference, though it doesn't match the usual patterns of human-made signals. It might have been a natural astronomical phenomenon, though we don't know what kind. It might have been exactly what it appeared to be, a narrow-band transmission from an artificial source, though without repetition, that remains speculation. The honest answer, 4 decades later, is that nobody knows for certain what caused the WOW signal. The evidence is consistent with multiple explanations, none of which can be definitively proven or disproven with the available data. This ambiguity is frustrating for people who want clear answers, but it's perfectly normal for science. The universe is under no obligation to reveal its secrets on demand, and some mysteries take longer to solve than others. Some might never be solved at all. You're back in that original moment, August 15th, 1977, thinking about all the things the WOW signal almost certainly wasn't. It probably wasn't, despite what some enthusiastic headlines suggested, a deliberate message from an alien civilization saying hello to anyone listening. Not because such messages are impossible, but because the characteristics of the signal don't quite match what you'd expect from an intentional transmission. An intentional message would likely repeat. If you're trying to communicate across interstellar distances, you'd broadcast your message multiple times, knowing that receivers might not be listening during your first transmission. You'd probably vary the message, encoding information rather than simply transmitting a carrier wave. The WOW signal showed no obvious encoding, no modulation that might carry information. It was just a strong signal at a specific frequency, appearing briefly and never repeating. The signal also came from a region of sky that doesn't contain any obvious targets for SETI searches. There are no nearby stars in that direction, no known exoplanets, nothing that would make an alien civilization choose that particular patch of sky as a broadcasting direction. Unless you assume the civilization is much farther away, in which case the signal would need to be extraordinarily powerful to reach Earth with the intensity the big ear detected. You're thinking about the geometry of interstellar communication, which gets complicated quickly. Space is three-dimensional and mostly empty. Broadcasting in all directions simultaneously requires enormous amounts of power. Most civilizations would probably use directional transmissions, beaming signals towards specific targets, rather than announcing their presence to the entire galaxy. If the WOW signal was such a directional beam, Earth happened to be in the right place at the right time to catch it, which is possible but seems statistically unlikely. The signal probably wasn't a distress call or warning, another popular interpretation that appears in speculative articles. Distress signals would presumably repeat continuously until help arrived, or until the transmitter failed. They'd probably contain modulation or encoding that marked them as urgent communication rather than simple carrier waves. The WOW signal had none of these characteristics. It appeared, it peaked, it faded, it disappeared. If it was communication that said very little. It probably wasn't a navigation beacon, the kind of thing a civilization might use to help spacecraft find their way through interstellar space. Navigation beacons would need to broadcast continuously or on a regular schedule. They'd probably transmit from fixed locations rather than appearing once and never repeating. Unless the beacon failed immediately after the big ear detected it, or unless it operates on a schedule measured in years or decades, making repetition difficult to observe within human timescales. You're considering the possibility that it wasn't a signal at all in the communicative sense, but rather some kind of industrial byproduct or technological leakage. Earth, after all, has been unintentionally broadcasting radio noise into space since the invention of radio. Television signals, radar emissions, radio stations all leak into space, creating an expanding bubble of electromagnetic radiation that announces humanity's presence whether we intend to or not. An alien civilization might have similar technology, and the WOW signal might have been their equivalent of someone leaving a radio on. The problem with all these speculative explanations is they require assuming the existence of the very thing you're trying to prove, an alien civilization with radio technology. Scientists prefer explanations that don't require assuming new, unproven entities. This principle, called parsimony, suggests you should explore all conventional explanations before invoking unconventional ones. Not because unconventional explanations are wrong, but because conventional ones are usually right. It probably wasn't a hoax, which some skeptics suggested early on. Creating a fake signal that perfectly mimics the characteristics of an astronomical source passing through a radio telescope's beam would require access to the telescope itself and detailed knowledge of how it operates. Jerry Eman and the other astronomers working with the Big Ear had no motive to fabricate data, and everything we know about how science works suggests that hoaxes don't survive scrutiny. The WOW signal has been scrutinized extensively, and it remains a genuine detection, even if its source remains mysterious. You're left with what the signal probably was, something real, something brief, something that hasn't repeated or hasn't been detected repeating. Beyond that, the possibilities branch into a tree of hypotheses, each with varying degrees of plausibility. The signal might have been a natural phenomenon that science hasn't fully characterized yet. It might have been interference from a terrestrial source that happened to mimic astronomical characteristics. It might have been a comet, though that explanation has weaknesses. It might have been something we haven't thought of yet. What the signal represents ultimately is the difference between data and interpretation. The data is clear. The Big Ear detected a strong narrow-band radio signal at 1420 MHz on August 15th, 1977. Everything else, every explanation, every hypothesis, every speculation about aliens or comets or unknown phenomena, is interpretation built on that single foundation of data. The data is solid. The interpretations remain provisional, waiting for additional evidence that might never arrive. You're standing in front of the Greenbank Telescope in West Virginia, the world's largest fully steerable radio telescope, and you're thinking about patience. The dish is enormous, 350 feet across, capable of detecting radio waves from the most distant regions of the observable universe. It's pointed at the sky, listening, just as radio telescopes have been listening since Karl Jansky first detected radio waves from the Milky Way's centre nearly a century ago. The telescope moves slowly, tracking objects as they arc across the sky. Inside the control room, computers process incoming signals, searching for patterns that might indicate something more interesting than random noise. The search continues, as it has continued for decades, with scientists knowing that they might spend entire careers listening to silence. SETI research requires a particular temperament, comfort with ambiguity, patience with negative results, and willingness to acknowledge that the search might ultimately prove futile. You're thinking about the Drake equation, formulated by Frank Drake in 1961 as a way to estimate the number of communicative alien civilizations in the Milky Way galaxy. The equation multiplies together factors like the rate of star formation, the fraction of stars with planets, the fraction of planets that could support life, the fraction where life actually develops, the fraction where intelligent life evolves, the fraction that develops technology capable of interstellar communication, and the length of time such civilizations broadcast detectable signals. The equation is less a calculation than a framework for thinking about the problem. Most of the terms are unknown or poorly constrained. How common is life in the universe? Nobody knows. How often does life develop intelligence? Unknown. How long do technological civilizations last before destroying themselves or moving beyond radio communication? Your guess is as good as anyone's. The Drake equation organizes ignorance more than it provides answers. Recent discoveries have constrained at least one term in the equation. Planets appear to be common. The Kepler Space Telescope and other planet-hunting missions have discovered thousands of exoplanets orbiting distant stars. Some are gas giants like Jupiter. Others are rocky worlds like Earth. Some orbit in their star's habitable zone, the region where liquid water could exist on a planet's surface. The galaxy contains billions of planets, possibly more planets than stars. But planets aren't civilizations. A planet might have life without having intelligence. It might have intelligence without having technology. It might have technology without having radio transmitters. It might have radio transmitters but choose not to broadcast, or might have broadcast millennia ago and then stopped, or might not yet have developed radio technology. The existence of planets makes life elsewhere seem more plausible, but it doesn't guarantee that anyone's transmitting signals Earth can detect. You're watching as the Greenbank Telescope participates in Breakthrough Listen, the most comprehensive SETI search ever conducted. The programme, funded by private donors, is surveying 1 million stars and 100 nearby galaxies, listening across a wide range of radio frequencies. It uses sophisticated signal processing to distinguish between natural radio sources, terrestrial interference, and potentially artificial transmissions. The search generates enormous amounts of data, all of which must be carefully analysed. The work is mostly automated, with computers scanning incoming signals for anything unusual. But humans still review the most promising candidates, checking for characteristics that might indicate intelligence rather than natural phenomena or human-made interference. Most candidates get quickly dismissed. They're satellites, aircraft, radio transmitters, cosmic noise, the usual suspects. Occasionally something unusual appears, gets investigated, and turns out to have a mundane explanation. This is the reality of SETI work. Hours and hours of finding nothing, interrupted by brief moments of excitement that fade when further investigation reveals natural or human causes. It's the opposite of dramatic. There are no eureka moments, no sudden revelations. Just patient, methodical observation and analysis, accumulating negative results while maintaining the hope that eventually one signal might resist all conventional explanations. You're thinking about why the search continues despite decades of silence. Part of it is the sheer magnitude of what's being searched. The galaxy contains somewhere between 100 and 400 billion stars. Surveying 1 million stars sounds impressive until you realise it represents a tiny fraction of the total. It's like dipping a cup into the ocean and concluding, based on that sample, whether the ocean contains whales. The search is also limited by time and frequency. Telescopes can only observe one patch of sky at a time, and radio telescopes can only listen to a limited range of frequencies simultaneously. A civilization might broadcast in frequencies we haven't searched, or might have broadcast millennia ago before humans were listening, or might broadcast millennia from now after current SETI projects have ended. The search is looking for a very small needle in an unimaginably large haystack, with no guarantee the needle exists. Yet the search continues, driven by a simple logic. The only way to know if anyone's broadcasting is to listen, and the only way to know listening is futile is to try it comprehensively first. Not searching guarantees you'll never find evidence of other civilizations. Searching doesn't guarantee success, but at least it provides a possibility, however remote. The silence of the cosmos might mean nobody's there, or it might mean we haven't listened long enough, carefully enough, or in the right directions. You're sitting in that Mesopotamian meadow again, though now you understand things that ancient stargazer couldn't have imagined. You know the stars aren't holes in a celestial sphere, but distant suns, many with their own planets. You know the Milky Way smear across the sky is actually your home galaxy, seen from the inside, containing hundreds of billions of stars spread across tens of thousands of light years. You know the universe is so vast that light from distant galaxies has been travelling toward Earth since before the solar system formed. But in some ways you're in exactly the same position as that ancient observer. You're still looking at the sky and wondering if anyone else is out there looking back. You have better tools, radio telescopes instead of naked eyes, computers instead of memory and guesswork, but the fundamental question hasn't changed. Are we alone in the universe, or is life common enough that somewhere among those billions of stars, someone else is also asking this question? The wow! Signal exists in that space between wonder and certainty, between speculation and proof. It's evidence of something, but exactly what remains unclear 4 decades after its detection. It might have been the first hint of cosmic neighbours, a brief hello from across the galaxy. Or it might have been a comet, a glitch, a natural phenomenon that momentarily mimicked an artificial signal. The data permits multiple interpretations, and without repetition, those interpretations remain provisional. You're thinking about how science treats this kind of ambiguity. The proper scientific response to the wow signal isn't to declare it definitely natural or definitely artificial, but to acknowledge uncertainty while continuing investigation. Science advances through accumulation of evidence, and one signal, no matter how intriguing, isn't enough evidence to support extraordinary claims. But it's sufficient evidence to justify continued searching, continued observation, continued openness to possibilities. The value of the wow. Signal might not be in what it proves, but in what it represents. It demonstrates that radio telescopes can detect strong, narrow-band signals from cosmic sources, or at least signal-like events that warrant investigation. It shows the importance of automated searches that can catch brief phenomena humans might miss. It illustrates both the promise and the frustration of SETI work. Sometimes you detect something interesting, but interesting isn't the same as conclusive. You're watching as new technologies expand the search for cosmic neighbours beyond radio wavelengths. Some researchers look for optical signals, brief laser pulses that might be easier to generate and transmit than continuous radio waves. Others search for signs of megastructures, massive engineering projects that might modify the light from distant stars in detectable ways. Still others look for chemical signatures in exoplanet atmospheres, combinations of gases that might indicate biological activity. The search has grown more sophisticated and more comprehensive, but it hasn't yet answered the fundamental question. 4 decades after the wow signal, the sky remains enigmatically quiet in frequencies humans are listening to. Either we're alone in this galactic neighbourhood, or our neighbours are silent, or we haven't yet learned how to listen properly. Each possibility is profound in its own way. Loneliness and companionship both reshape how you think about humanity's place in the cosmos. What wonder knows that certainty forgets is that questions can be valuable even without answers. The search for extraterrestrial intelligence forces humanity to consider its assumptions about life, intelligence, technology, and communication. It encourages thinking on cosmic scales, in time spans measuring thousands or millions of years. It requires maintaining hope in the face of repeated disappointment, which is either admirable persistence or stubborn refusal to accept obvious conclusions depending on your temperament. You're lying on your back again, looking at the same stars that ancient observers saw 5,000 years ago. The stars appear identical, though you know they've moved slightly, creeping across the sky as the galaxy slowly rotates. The light you're seeing left those stars years or decades or centuries ago, travelling across space at cosmic speed limits. If anyone on planets orbiting those stars is looking toward Earth, they're seeing Earth as it was when that light began its journey. Possibly before humans existed, definitely before humans developed radio technology. This is the challenge of interstellar communication, not just the vast distances but the vast timescales involved. Civilizations might rise and fall in the time it takes a message to travel between stars. A signal sent thousands of years ago might just now be arriving at Earth, transmitted by a civilization long extinct. Or Earth's signals might someday reach distant worlds, whose inhabitants evolved millions of years after those signals began their journey. Communication across the cosmos isn't like a phone conversation, but more like messages in bottles, cast into an ocean of space and time with no guarantee anyone will ever read them. The wow. Signal represents a moment when something unknown interrupted the cosmic quiet, however briefly. Whether it was aliens, comets, or something else entirely, it served as a reminder that the universe can still surprise us, that our understanding remains incomplete, and that some mysteries resist quick resolution. The signal appeared, was documented and vanished, leaving behind more questions than answers. That's frustrating if you want certainty, but it's perfectly appropriate if you're comfortable with wonder. You're at the Very Large Array in New Mexico, standing among the 27 radio dishes arranged in a Y-shaped configuration across the desert. Each dish is 82 feet in diameter, and they work together as a single telescope, combining their signals to create images of the radio sky with impressive resolution. The dishes can move on railroad tracks, adjusting their separation to change the telescope's capabilities. Right now, they're configured to observe distant galaxies, but later they'll participate in SETI observations, adding their considerable power to the ongoing search. The search for cosmic neighbours has become more sophisticated since the days of the Big Ear. Modern radio telescopes can observe multiple frequencies simultaneously, process vast amounts of data in real time, and distinguish between natural sources, interference, and potentially artificial signals with greater accuracy than earlier systems. Computers scan millions of channels, looking for the narrow band emissions that might indicate technological origin. The search continues across multiple wavelengths, from radio to optical, covering more sky with greater sensitivity than ever before. But increased capability doesn't guarantee detection. The Breakthrough Listen program has surveyed thousands of nearby stars without finding confirmed artificial signals. The search for extraterrestrial intelligence at UC Berkeley processes data from radio telescopes around the world, engaging millions of volunteers through distributed computing projects. The Allen Telescope Array in California, specifically designed for SETI work, observes the sky continuously. All report the same result: no confirmed detection of extraterrestrial intelligence. You're thinking about what this silence might mean. The simplest explanation is that technological civilizations are rare, possibly unique to Earth. Life might be common in the universe, but intelligence and technology might be evolutionary accidents that rarely occur. Or civilizations might typically destroy themselves before developing interstellar communication capabilities, making the window for detection vanishingly small. Or they might advance beyond radio technology quickly, using communication methods we can't detect or haven't imagined. Another possibility is that civilizations exist but deliberately avoid broadcasting. Announcing your presence to the cosmos is a gamble. You're revealing yourself to unknown neighbours who might be friendly, indifferent, or hostile. Some theorists argue that intelligent civilizations naturally become quiet as they mature, limiting their electromagnetic emissions to avoid detection. If everyone's hiding, then silence becomes the expected condition, and the wow signal might have been an accidental leak from a civilization that normally keeps quiet. Or perhaps civilizations communicate in ways that don't involve electromagnetic radiation at all. They might use neutrinos, gravitational waves, or technologies humans haven't discovered yet. They might communicate through means that are physically possible, but practically impossible for humanity's current technology to detect. The search assumes that radio waves are a universal communication medium, which might be wrong. We're looking for keys under the streetlight, not because that's where we lost them, but because that's where the light is good. You're watching the sun set over the very large array, painting the dishes orange and gold in the fading light. The telescopes will observe through the night, as they always do, collecting radio waves from across the cosmos. Most of what they detect will be natural phenomena, supernova remnants, pulsars, galaxies, quasars, all the usual astronomical sources. The data will be stored, analysed, and added to the growing archive of observations that constitute humanity's map of the radio universe. Somewhere in that data might be another signal like the wow signal, brief and strange and resistant to easy explanation. Or maybe not. The universe is under no obligation to provide mysteries on a schedule convenient for astronomers. The search continues not because success is guaranteed, but because the question is important enough to justify the effort. Are we alone in the universe? The only way to answer that question is to look, and keep looking, even if the cosmos remains silent. You're thinking about patience again, which seems to be the defining characteristic of SETI research. Patience to search millions of stars knowing most won't yield results. Patience to develop better instruments and techniques while acknowledging that better tools don't guarantee better outcomes. Patience to maintain funding and public interest in a search that might never find what it's looking for. Patience to accept that the most likely result of any given observation is finding nothing unusual. This patience isn't resignation, but rather appropriate calibration of expectations. The search for extraterrestrial intelligence is looking for extremely rare events, possibly unique events, against a background of common natural phenomena and terrestrial interference. It's reasonable for such a search to take decades or longer. The absence of quick results doesn't mean the search is failing. It might mean the search is proceeding exactly as expected given the challenge's magnitude. The stars emerge as the sky darkens, familiar constellations appearing in their expected positions. Sagittarius rises in the east, containing the coordinates where the Big Ear detected the wow signal 47 years ago. The region looks like any other patch of sky, a random scattering of stars with no obvious distinguishing features. If something unusual is there, broadcasting or waiting or simply existing, it keeps its secrets well. You're left with questions instead of answers, which is an honest place to be. The wow signal remains unexplained, a 72-second mystery that refuses to yield to conventional analysis. Maybe someday another telescope will detect a similar signal, or the same signal repeating, and the mystery will resolve into something understandable. Maybe the signal will remain unique, a single puzzling data point in decades of observation. Maybe an entirely different discovery will make the wow signal seem quaint, a historical footnote in humanity's eventual contact with cosmic neighbours. Or maybe the search will continue for centuries without finding definitive proof that anyone else is out there, and humanity will remain alone in the observable universe, talking to ourselves, sending messages into the void that nobody receives because nobody exists to receive them. That outcome would be disappointing but also remarkable in its own way. Being alone in the cosmos would make humanity and Earth and the entire story of life on this planet extraordinarily precious, unique events in a universe where such events are vanishingly rare. The radio telescopes point skyward, patient and tireless, listening to the whispers of distant galaxies and the hiss of cosmic microwave background radiation. They wait for a signal that stands out, that breaks the pattern, that suggests intelligence rather than natural processes. They've been waiting for decades. They might wait for centuries more. The search continues not because it's easy, or because success is guaranteed, but because the question matters enough to justify the patience, the resources, the hope that somewhere among the stars someone else is also searching, also wondering, also hoping to find neighbours in the vast dark. The night deepens, the stars brighten, and the listening continues. The Earth has always kept better secrets than stone tablets or papyrus scrolls. Long before museums and archives, people understood that the safest way to preserve what mattered most was to hide it beneath their feet, trusting soil and silence to protect knowledge until the right moment arrived. This is the story of those deliberate concealments, the things buried not to be forgotten, but to be remembered at precisely the right time. The jar feels cool against your palms even though the Egyptian sun has been beating down on this courtyard for hours. You're crouched in what used to be someone's home, maybe 1500 years before the Romans showed up to reorganize everything. The dwelling sits on the outskirts of Akhetaten, the city that will eventually be called Amarna by people who never knew its original name. Right now, in this moment around 1330 BCE, the place still hums with the particular chaos of a capital city that sprang up too fast and might not last much longer. Your knees ache from squatting in this position, but you're committed now. The jar you're holding is heavy, made from Nile clay that someone fired carefully enough to last. It's sealed with wax and linen, which seems excessive for storing grain or oil. Your neighbours have been whispering for weeks that the old order might return soon, that the priests who got pushed aside when Akhenaten decided everyone should worship his sun disk are sharpening their metaphorical knives. Change is coming, which means danger for anyone too closely associated with the current way of things. Inside this sealed jar are three things: a small statue of Aten, the sun disk deity that Akhenaten insists is the only god worth mentioning, a handful of hymns written on pottery shards because papyrus is too expensive for someone like you, and a bronze mirror that reflects your tired face when you peek inside one last time. These objects mean something to you. They represent the last 15 years of your life, a period when it felt like the divine might actually care about regular people instead of just aristocrats and priests. You know that opinion is about to become dangerous. The hole you've dug beneath your floor is deeper than necessary. You've gone down past the packed earth, past the layer of older debris, into soil that feels different, ancient somehow, untouched. You wrap the jar in linen, then lower it carefully. Your hands are shaking, which surprises you. You've buried food stores before, hidden valuables when raiders came through, but this feels different. You're not hiding treasure from thieves. You're hiding belief itself, preserving it for a future you'll never see. As you shovel dirt back over the jar, you wonder if anyone will ever find it. Part of you hopes they won't. These objects only matter to people who shared this particular moment, this brief window when the world seemed to tilt toward something new. 100 years from now, maybe 200, they'll just be curiosities, broken pottery and tarnished bronze. The reverence will be gone, soaked away into the earth along with your intentions. But you pack the earth down firmly anyway, then scatter ash from the fire pit across the surface to make it blend in. You'll put a grinding stone here tomorrow, something heavy and utilitarian that no one would think to move. The secret will be safe, whatever that means. The irony doesn't escape you. You're preserving a religion that claimed to worship light and openness by burying it in darkness. But concealment has its own honesty. You're admitting that some truths can't survive in the open air of politics and power struggles. They need the Earth's patience, its willingness to hold things without judgment until conditions change. 3,000 years later, when archaeologists sift through this exact spot, they'll catalogue your jar as votive deposit or personal cult cache. They'll photograph the contents, analyse the clay composition, radiocarbon date the linen. They'll never know you knelt here with aching knees and shaking hands, making a choice that felt enormous in the moment but will register as a minor footnote in papers about daily life during the Amarna period. Your act of desperate preservation will become data. But right now, standing up and brushing dirt from your knees, you don't know any of that. You only know that you've done what you could. The rest belongs to time, that patient excavator that eventually uncovers everything. The manuscript weighs less than you expected, but then parchment never has much heft, even when it's covered in careful script. You're standing in the library of Lindisfarne Monastery, off the northeastern coast of Britain, in the year 793. Outside, the North Sea makes that endless rushing sound that you've gotten used to, but never quite stops noticing. Today the sound feels ominous, though maybe you're projecting. The prior came back from the mainland yesterday with news that makes your stomach tight. Ships with unusual sails have been spotted. Not the trading vessels you're used to, the ones that bring salt and metalwork in exchange for the monastery's famous illuminated books. These ships move differently, low in the water and fast. The messenger who told the prior about them had that particular pale look that means he's seen something he can't quite bring himself to describe fully. In your hands is a copy of the Gospels that took Brother Edfrith 3 years to complete. You've seen him working on it, hunched over his desk in light so carefully angled that it doesn't cast shadows across the page. The gold leaf alone represents weeks of work. Applying it requires patience that would make a stonecarver weep. The illustrations in the margins contain more colours than you knew existed, and you've lived near this monastery your whole life. The decision to bury the book came from the abbot, but you're the one who volunteered to do it. Partly because you're young enough to make the trip up the coast without your knees giving out, and partly because you understand what's about to happen in a way some of the older monks don't want to acknowledge. Raiders don't come for theological discussions. They come for gold and silver, for anything that can be melted down or traded. A book like this, with its jewelled cover and gilt edges, looks like wealth. The fact that it contains the word of God won't slow anyone's axe. You've chosen a spot 3 miles up the coast, in a cave that fills with seawater during high tide, but stays dry in its upper reaches. It's the kind of place you explored as a child before you started helping at the monastery, back when the coastline was just a playground rather than a strategic consideration. The cave has a narrow entrance. You have to turn sideways to slip through, which means it's not the kind of place raiders would bother with. No storage space, no living quarters, nothing worth the effort. Inside, you've already placed the oiled leather wrapping that will keep moisture away from the parchment. The monks gave you their best materials for this task. They understand they're not just preserving a book, they're preserving hours of human attention, the kind of concentrated focus that borders on prayer. Every letter in this manuscript represents a choice. Where to thicken the stroke, how to shape the curve, which pigment to mix. Destroying it would be like burning years of someone's life. You wrap the book carefully, then place it in a wooden box that's been coated with beeswax. The box goes into a leather satchel, and the satchel goes into a niche in the cave wall that you've lined with stones. You stack more stones in front of it, arranging them to look natural, like they've always been there. A casual observer wouldn't notice anything unusual. You're counting on raiders being casual observers when it comes to empty caves. The work takes longer than expected. Your hands keep wanting to rush, to finish, and get back to the relative safety of the monastery. But rushing would mean doing this poorly, and the entire point is to do it well enough that the manuscript survives whatever comes next. So you slow down, check each stone placement, Make sure the niche is completely hidden. The tide is starting to come in by the time you finish. You have to wade through ankle-deep water to get out, holding your shoes above your head and trying not to slip on seaweed-covered rocks. Walking back, you rehearse what you'll tell the abbot. The location is memorized, 3 miles north, past the distinctive rock formation that looks like a bishop's hat. The cave with the narrow entrance just above the tide line. You'll draw a map, hide it somewhere safe. The secret needs to survive even if you don't, which is suddenly feeling like a real possibility rather than abstract worry. The raiders come 2 days later. You watch from the hills as they beach their ships and move through the monastery with systematic efficiency. They're not random vandals. They know exactly what they're looking for, which buildings hold the most valuable items. The screaming doesn't last long. Monks aren't fighters, and resistance would be suicide. You see books being thrown into piles, probably to check for anything valuable tucked between pages. Most get left scattered in the mud. They're useless to people who can't read Latin. You survive by running, which makes you feel like a coward until you remember the manuscript hidden 3 miles up the coast. Cowardice with a purpose is just strategy. The prior told you that once, though he probably didn't mean it to apply to fleeing while your friends died. 1,200 years later, someone exploring that same cave will find the box purely by accident. They'll be looking for smugglers' caches or natural artifacts, not religious texts. The manuscript inside will be water damaged and fragmentary, but enough will survive to make scholars excited. They'll marvel at the preservation technique, the quality of the materials, the skill required to create something so beautiful in such a remote location. They'll write papers about workshop practices and artistic influences. They probably won't think much about the terror that motivated the burial. History tends to sand down those edges, leaving behind clean narratives about cultural preservation and artistic achievement. The desperate scramble, the calculations about death and survival, the guilt of running while others stayed, those don't make it into museum placards. You just get credited with having the foresight to preserve an important artifact. But you didn't feel foresightful, stumbling through that cave with shaking hands and watching the tide come in. You felt terrified and small and painfully aware that everything you knew was ending. The concealment wasn't strategic. It was animal instinct dressed up as preservation. The manuscript survives anyway. Sometimes panic makes better long-term decisions than planning. The smell is what you'll remember later, even more than the fear. Smoke has a particular character when it's consuming books, something acrid and complex, like breathing in centuries of accumulated thought. You're standing in the courtyard of a private library in Cordoba, in what will eventually be called Spain, in the year 976. The Umayyad Caliphate is in one of its periodic upheavals, which means yesterday's acceptable scholarship is today's dangerous heresy. The library belongs to a merchant named Ibrahim, though ownership is becoming a complicated concept. Ibrahim himself left 3 weeks ago, reading political winds with the same skill that made him wealthy. He took his immediate family, his portable wealth, and about 20 books small enough to hide in saddlebags. Everything else, including you, his librarian, and the remaining 4,000 volumes, got left behind for someone else to deal with. That someone is you, which seems unfair but not surprising. You've spent 15 years organising this collection, creating catalogues, tracking down copies of texts that existed only as rumours. You know which shelf holds the only complete manuscript of a particular mathematical treatise. You know which corner contains poetry that would get people executed if the current regime found it. You know the value of every single item in this building, measured in both money and irreplaceability. The mob outside knows none of this. They know that Ibrahim was associated with the previous administration, and that's enough. They know this building contains books, and certain religious authorities have declared that most learning leads to corruption. They don't know that you've spent the last 3 weeks carefully selecting 30 volumes, not the most valuable or the most beautiful, but the most unique, and burying them in locations around the city. The jar hidden in the foundation of the abandoned mosque on the eastern edge of town contains 6 mathematical texts, including one on algebra that exists nowhere else in the Western world. The cache beneath the old Roman cistern holds poetry and philosophy, works that people might want to read again someday when politics shifts. Under your own floor, in a waterproof chest, you've placed the histories, chronicles of events that someone will eventually want to verify once the current passion for rewriting the past subsides. You didn't save everything. That would be impossible. But you saved something which feels simultaneously adequate and completely insufficient. Standing here now, watching smoke begin to curl from the library's upper windows, you're doing calculations about regret. Should you have taken more risks, hidden more books, found a way to smuggle them out of the city entirely? The thing about selective preservation is that it requires you to make impossible choices. Every book you buried meant abandoning 10 others. Every text you deemed important enough to save implied that others weren't. You've essentially declared yourself the arbiter of what future generations deserve to inherit, and the weight of that feels like it might crush your chest. The fire is spreading faster than you expected. The library's roof is wooden, and the summer heat has made everything tinder dry. You watch flames climb through rooms you could navigate blindfolded, consuming organizational systems that existed only in your memory. The section on astronomy goes first, 3rd floor, western corner, where the light was best for examining star charts. Then the poetry alcove, the medical texts, the collection of travel narratives that you loved reading during slow afternoons. Someone in the mob is shouting about cleansing corruption. The irony would be funny if it weren't so destructive. They're burning a repository of Islamic scholarship in the name of Islamic purity, destroying texts that scholars spent lifetimes creating and copying. But nuance doesn't survive contact with crowds. You learned that quickly over the past few weeks. The concealment you engaged in wasn't about preserving knowledge from invaders or foreign armies. It was about protecting thought from its own civilization. That's a different kind of burial, one that comes with its own particular shame. You weren't hiding from external threats. You were hiding from your neighbours, from people who share your language and religion and city. The enemy wasn't outside the walls. The enemy was the wall itself, closing in around ideas. 600 years later, someone will discover the jar beneath the cistern while doing construction. The books inside will be damaged but legible, and scholars will be excited to find texts they knew existed only from references in other works. They'll write papers about transmission of knowledge, about how certain ideas survived periods of upheaval. They'll treat your buried cache as evidence of cultural continuity. They probably won't think much about the selection process, about all the books that didn't make it into those jars. History remembers what survives, not what burned. The gaps in the record become invisible, filled in by imagination, or simply ignored as unknowable. Your agonizing choices about what to save will be hidden beneath celebration of what was preserved. But right now, watching the library collapse in on itself with a sound like the world cracking, you're very aware of the gaps. You know exactly which texts are turning to ash. You can recite titles, describe bindings, recall the specific shade of ink used by particular copyists. The absence has weight and specificity. It's not abstract loss. It's the destruction of particular things you knew individually. You'll carry that inventory for the rest of your life, a catalogue of everything that didn't make it. The buried books will feel less like salvation and more like inadequate memorial, a tiny fraction preserved to mark the magnitude of what was lost. But you'll tend them anyway, checking periodically to ensure the hiding places remain secure. Not because you believe they'll be found and appreciated, but because giving up on them would mean admitting the burning won. Sometimes preservation is just stubbornness with better planning. The jar in your hands is ordinary to the point of being boring. Brown clay, functional shape, no decoration beyond a few finger-pressed ridges around the rim where the potter's hand slipped while throwing it on the wheel. You're standing in what used to be your kitchen, in a village whose name will be forgotten, long before archaeologists assign it a catalogue number. The year is somewhere around 600 BCE, give or take a few decades. Nobody's counting precisely because counting years isn't something your community considers important. What is important right now is the fact that the jar contains something your grandmother gave you. A small bronze figurine, barely the size of your thumb, depicting a goddess whose name you don't know, but whose presence feels significant. Your grandmother received it from her grandmother, who received it from someone even further back. The chain of possession extends into time that nobody bothered recording. The figurine is old, older than anyone's memory, which gives it a particular kind of authority. The problem is that the village priest has been making speeches lately about proper worship and authorised deities. He's got backing from the regional temple, which has decided to standardise religious practice across several villages. Standardisation apparently means destroying personal shrines and family heirlooms that don't align with official pantheons. You've seen neighbours hauled in for questioning about their devotional habits, which would be darkly funny if it weren't so threatening. You're not particularly devout. The figurine matters to you because your grandmother's hands held it, not because you believe it channels divine power, but explaining that distinction to someone invested in religious conformity seems unlikely to end well. So you're doing what people have done for thousands of years. When official orthodoxy conflicts with personal attachment, you're hiding the evidence. The burial spot you've chosen is in the corner of what used to be your family's grain storage area, back when the family had enough grain to require dedicated storage. Now it's just a dirt floor and stone walls, but the corner still feels appropriate. You dig down about 2 feet, which is deeper than necessary but makes you feel more secure. The hole is wider than the jar by several inches, which lets you line it with clean sand before placing the vessel inside. Before sealing the jar, you take one last look at the figurine. The bronze has that greenish patina that old metal develops, and one of the arms is broken off at the elbow. In better light, you could probably make out details of the face, but the sun is setting, and you're trying to finish this before dark. You wrap the figurine in a scrap of wool cloth, not for any ritual purpose, just to keep it from rattling around, and place it in the jar along with a small clay lamp that also belonged to your grandmother. The lamp is less emotionally significant, but including it makes the cache feel more deliberate, less like you just buried trash. You have standards, even when hiding things from religious authorities. Sealing the jar takes longer than expected. You're using beeswax mixed with tree resin, heated until it becomes liquid enough to pour but not so hot that it cracks the clay. Getting the temperature right requires attention, and you're distracted by the sound of voices from the main path. Probably just neighbours walking home, but every sound makes your shoulders tense. You're not technically doing anything illegal. Not yet. But the space between legal and questionable has been shrinking lately. Once the wax sets, you lower the jar into the hole and begin filling dirt back in. Your technique is sloppy, motivated more by nervousness than care. You'll regret that later when you can't remember the exact location, but right now, you just want this finished. The dirt gets tamped down, smoothed over, and covered with loose straw to match the rest of the floor. An observer would have to look carefully to notice any disturbance, and you're betting that most observers won't look carefully. The concealment feels anticlimactic. You expected some sense of completion or accomplishment, but mostly you just feel tired and slightly ridiculous. You've buried a broken bronze figurine and an old lamp in a dirt floor. Future archaeologists will catalogue this as a ritual deposit or votive offering, inventing elaborate theories about your motivations and beliefs. They'll analyse the placement, measure the depth, compare the artefacts to similar finds from the period. They'll be wrong about almost everything. There was no ritual, no offering, no elaborate belief system at work. Just someone trying to keep family objects away from religious busybodies, using the oldest security system in the world. Putting things underground and hoping nobody looks there. 3,000 years from now, someone will indeed find your jar. They'll write papers about continuity of goddess worship, about how old religious practices persisted in domestic contexts despite official prohibition. They'll photograph the figurine from multiple angles, analyse the bronze composition, compare its iconography to regional traditions. The broken arm will be carefully noted in the condition report. What they won't know is that you barely remember which goddess the figurine depicts. That your grandmother told you once, but you weren't paying attention because you were young and immortal, and couldn't imagine caring about family heirlooms, that the burial was practical rather than devotional, motivated by fear of harassment rather than religious conviction, that you were just trying to avoid trouble, not preserve sacred mysteries for future generations. But history has a way of upgrading motivations. Your pragmatic concealment becomes evidence of religious resistance. Your forgetting becomes deliberate mystery. Your ordinary clay jar becomes a ritual vessel. The gap between what happened and what gets recorded is filled with interpretation that makes everything sound more intentional than it was. You finish smoothing the floor and step back to examine your work. The burial spot is invisible, which was the goal. Whether you'll remember where you put it in a few years is questionable, but that problem belongs to future you. Present you is just relieved to have this finished. Tomorrow you'll go about your regular business, and probably nothing will happen. The priest's enthusiasm for standardization might fade once he realizes how much work it requires, or the regional temple might get distracted by some other issue, or maybe enforcement will intensify, and you'll be grateful for your paranoid afternoon of burial. The uncertainty is exhausting. You don't know if you've preserved something important or wasted an afternoon hiding garbage. You don't know if anyone will care, now or ever. You just know that the alternative, letting the figurine be destroyed or confiscated, felt worse than the effort of concealment. So you've chosen the Earth's patience over immediate clarity. You've bet on burial as preservation, on concealment as the highest form of honouring what came before. Whether that bet pays off is someone else's problem. Generations removed from this moment and all its mundane anxieties. For now, you have an invisible jar in an unmarked spot, a secret that might never need to be revealed. It's not heroic or dramatic. It's just practical magic. The everyday miracle of making things disappear by putting them where nobody thinks to look. The tablet is surprisingly heavy for something that's mostly clay and resentment. You're holding it in both hands, standing in what passes for an office in this provincial backwater of the Akkadian Empire, around 2300 BCE. The tablet contains administrative records, grain distributions, labour assignments, the kind of bureaucratic detail that makes empire function, but bores everyone involved in creating it. The writing is cuneiform, pressed into wet clay with a reed stylus, then baked until the words become permanent. Permanent is a relative concept you're learning. The empire is fragmenting, which you know because tax collection has become sporadic, and the governor stopped showing up to meetings months ago. When central authority collapses, provincial archives become liabilities. Whoever takes over next might have questions about who supported the previous administration, who benefited from particular policies, who can be safely purged versus who needs to be co-opted. Your name appears in these records. Not prominently, you're not important enough for that, but frequently. You distributed grain, assigned labour, collected taxes on behalf of administrators who are now conveniently absent. On some of these tablets, you're the only authority figure mentioned, which means when the new regime starts looking for people to blame or examples to make, your name will surface immediately. The sensible response would be to destroy the tablets entirely, smash them, grind them to powder, scatter the fragments so thoroughly that reconstruction becomes impossible. But you've spent 5 years creating these records, maintaining an accounting system that actually works, keeping track of details that more senior officials couldn't be bothered with. The tablets represent competence in a world that doesn't produce enough of it. Destroying them feels like erasing your own existence. So you're compromising. You're selecting the most problematic tablets, the ones that connect you too directly to unpopular policies, and burying them in a sealed room in the archive building's foundation. Not destroyed, but unavailable. Hidden from whoever conducts the inevitable purge of administrative records. The burial chamber is tiny, barely large enough to crouch in. It was originally a storage niche that got sealed up when someone built an addition to the archive. You've reopened it by carefully removing stones from the wall, working at night when the building is empty. Inside, you've placed wooden shelves to keep the tablets organised, because even in concealment you can't quite abandon your professional standards. The tablets you're burying tonight document grain shipments that bypassed normal distribution channels during a famine 3 years ago. You remember that situation vividly. People were starving. Official channels were clogged with bureaucratic requirements, and someone needed to act quickly. You did. You authorised emergency distributions using authority you didn't technically have, then created documentation after the fact to make it look legitimate. It worked. People ate. Nobody died. Nobody even questioned your authority because you seemed confident and had official-looking tablets to justify your decisions. But those tablets could now be read as evidence of corruption, unauthorised resource allocation, falsification of records. Whether you saved lives or committed fraud depends entirely on who's reading and what they want to prove. You stack the tablets carefully on the shelves, organised by date and type of transaction. The temptation to add some kind of explanatory note is strong. A message to future readers explaining context, defending decisions, making sure your motivations are understood. But that impulse is stupid. Anyone finding these tablets won't care about your justifications. They'll either be looking for evidence to condemn you, or they'll be so far removed from this moment that context won't matter. The other tablets on these shelves document similar situations, decisions that made sense at the time but look questionable in record form, compromises necessitated by reality but unexplainable to people who weren't there, the gap between what happened and what got written down, then the gap between what got written down and how it might be interpreted. You're burying layers of translation failure. Once the shelves are full, you begin sealing the chamber. The stones go back in carefully, mortared with clay that matches the surrounding wall. You work slowly, making sure the repair is invisible. By tomorrow morning, this will look like solid wall, just another section of archive foundation. The tablets inside will begin their long wait for discovery, for reinterpretation, for whatever future makes of your buried bureaucracy. What you don't know, can't know, is that these tablets will remain hidden for over 4,000 years. The archive building will collapse and be rebuilt multiple times. The city itself will be abandoned, buried under windblown sand, forgotten so completely that even its name survives only in garbled references in other documents. Your carefully sealed chamber will be missed by the first wave of archaeologists, then the second, then the third. When someone finally breaks through that wall in the 1990s CE, they'll find your tablets in surprisingly good condition. Dry climate, sealed chamber, clay that was properly fired, all the preservation factors aligned. They'll carefully extract each tablet, photograph it in place, create detailed documentation of the fine context. They'll be excited because sealed archive chambers are rare and valuable. Then they'll begin translating the cuneiform and confusion will set in. These aren't the kind of records archaeologists expect to find hidden. There's no treasure, no royal correspondence, no religious texts. Just grain distributions and labour assignments, the administrative minutiae of a small provincial office. Why would someone seal these up? What's significant about routine bureaucracy? They'll develop theories. Perhaps this was a time capsule, an attempt to preserve records during political instability. Perhaps these tablets were being protected from destruction by invading forces. Perhaps there's some kind of pattern in the records that reveals important information about economic conditions or social structure. All the theories will be wrong because they assume importance. They assume someone buried these tablets because they mattered, because they contained valuable information worth preserving. They don't account for the possibility that you buried them to make them disappear, to remove evidence of decisions that might get you executed. Concealment is self-preservation rather than cultural preservation. The irony will be invisible to future scholars. By hiding these tablets, you'll ensure their survival. The records that remained in open archives got destroyed or scattered centuries ago. But your buried evidence of administrative improvisation will last longer than the empire it documented, preserved by the very attempt to make it vanish. You finish sealing the wall and step back to examine your work. The repair is clean enough that casual inspection won't reveal anything. You sweep away stone chips and scattered clay, restoring the area to its usual appearance of neglected storage space. Tomorrow you'll begin selectively destroying other records, the ones that can't be easily hidden but need to disappear. It's going to be a long week of careful arson and strategic memory loss. But tonight, you've done what you can. You've created a gap in the record, a a space where your most questionable decisions can hide from immediate consequences. Whether that space eventually becomes discovery or remains permanent concealment isn't something you can control. You've just pushed the problem forward in time, trusting that distance will provide safety. The Earth accepts your bureaucracy without judgment. Soil doesn't care about grain distributions or administrative authority. It just holds things, patient and indifferent, until someone decides to look. You're betting that nobody will, or at least that by the time they do, the context will be too distant to matter. It's not a perfect plan, but perfection stopped being an option when the empire started collapsing. Now you're just trying to survive with minimal consequences, using the oldest strategy available, making yourself invisible by putting your evidence underground. The pot you're wrapping in old cloth is ugly even by utilitarian standards. It's lumpy, unevenly fired, decorated with patterns that suggest the potter had seen better work but couldn't quite replicate it. You're packing it anyway because ugly pots are still useful, and you're about to leave this village without much opportunity to be selective about household goods. The year is around 900 CE, somewhere in what will eventually be called Peru, in a valley system that supports your community through a combination of farming and stubbornness. The reason for leaving is tedious. There's drought, there's political pressure from the growing Wari state, there's internal disagreement about how to respond to both problems. The details don't matter as much as the result, which is that about half the village is relocating to a valley further south, where cousins have agreed to share resources. You're going with them, which means abandoning the home your family has occupied for at least 3 generations. Abandonment requires decisions about what to take and what to leave behind. The useful goes with you. Tools, seeds, textiles, anything valuable or necessary. But there's a category of objects that exist in the gap between useful and disposable. Things that have meaning but no practical function, or objects that are functional but too heavy to carry, or items that represent time and effort but not enough value to justify the space they'd occupy in your limited baggage. Your ugly pot falls into this category. It was made by your daughter when she was first learning pottery, back before she got sick. She's been dead for 2 years now, which is long enough that the grief doesn't ambush you constantly, but recent enough that her absence still creates holes in your daily routines. The pot is a clumsy record of her hands learning a craft, of afternoons spent working clay while you prepared food nearby. Taking it would mean carrying extra weight for purely sentimental reasons. Leaving it would mean abandoning one of the few tangible connections to those afternoons. The compromise you've arrived at is burial, not destruction, but removal from circulation. You're going to cache certain objects in locations around the abandoned village, hidden well enough that casual scavengers won't find them, but marked carefully enough that you could theoretically return someday and retrieve them. Theoretically. You know you're probably never coming back. But the pretense of possible return makes the burial feel less permanent than abandonment. The spot you've chosen for your daughter's pot is in the storage room of your house, in a corner where water damage has already weakened one wall. You dig down about 18 inches, which is easier than expected because the floor here is mostly fill from previous constructions. The village is old enough that you're digging through layers of other people's refuse and rebuilding. Someday your layer will be someone else's fill dirt, if there's anyone around to do building. You place the pot in the hole without ceremony. Adding ritual would make this feel too much like burial, and you're trying to maintain the fiction that this is just temporary storage. The cloth wrapping will help protect against moisture, though honestly the pot is already so poorly fired that a little water damage won't make much difference. You add a few other items to the cache. A broken grinding stone that your grandmother used, a ceramic whistle that doesn't work properly anymore, a chunk of pyrite that your daughter collected because it was shiny. None of these objects have monetary value. None would be worth stealing. They're personal in the most private sense, meaningful to you specifically, useless to anyone else. But combined, they represent the texture of your life in this place. The small accumulations that make a house feel inhabited rather than just occupied. Filling in the hole feels more final than you expected. Each handful of dirt is a small burial, a minor ending. You work slowly, partly because you're tired and partly because rushing would feel disrespectful to the objects below. When the floor is level again, you scatter ash and pottery shards across the surface to blend the disturbed area into its surroundings. Tomorrow, when you leave, this corner will look like any other part of an abandoned room. The thing about burying objects nobody wants is that they tend to stay buried. There's no incentive for treasure hunters or looters to dig through old houses looking for broken pottery and used grinding stones. Professional excavators might find them eventually, but only if they're systematic about excavation, treating every layer and feature with equal attention regardless of obvious value. 1400 years later, someone will indeed excavate this corner of your house. They'll be part of an archaeological survey documenting abandoned settlements in the valley system. Your cache will be notable primarily for being intact. Most of the rooms in the village show signs of disturbance from later occupation or animal activity. But this corner with its water-damaged wall was apparently too unpleasant for anyone to bother with. The excavator who finds your pot will recognise immediately that it's not a masterwork, but they'll also recognise that it's handmade, probably by someone learning the craft. They'll catalogue it carefully, note its find spot, analyse the clay composition. The other items in the cache will receive similar attention, measured, photographed, added to the site database. Then comes interpretation, which is where things get speculative. The excavation report will suggest this cache might represent a ritual deposit, possibly related to household abandonment practices. The combination of broken tools and personal items suggests intentional placement rather than casual discard. Perhaps this was an offering to ensure safe departure, or a way of maintaining spiritual connection to an abandoned dwelling. They'll be overthinking it. You weren't performing ritual. You weren't maintaining spiritual connections. You were just sad and reluctant to throw away your daughter's pottery. The burial was emotional management, not religious practice. But archaeology has trouble with ordinary sadness. It's not dramatic enough to explain carefully placed deposits. So emotional management gets upgraded to spiritual practice. Private grief becomes cultural pattern. The misinterpretation doesn't really matter. Your cache will be preserved and documented regardless of whether scholars understand your motivations. The objects will end up in storage at a research facility, available for future study. Your daughter's ugly pot will outlast the drought that drove you away, outlast the empires that rose and fell in this valley, outlast memory of the language you spoke while wrapping it in cloth. All because it was worthless enough that nobody bothered to dig it up looking for treasure. That's the accidental genius of burying things nobody wants. They survive through neglect rather than intention. The valuable items get found and removed. The obvious treasure gets looted. But the ordinary objects, the ones with only personal significance, stay buried simply because nobody has a reason to look for them. They wait patiently underground, protected by their own lack of value, until someone decides to excavate systematically rather than selectively. You finish covering the cache and stand up, brushing dirt from your hands. The room looks the same as it did an hour ago, abandoned, water-damaged, not worth anyone's attention. Perfect camouflage for objects that only matter to one person. Tomorrow you'll walk away from this place, heading south with your remaining possessions and diminishing hope. But part of your life will stay here, buried in a corner that nobody will care about for over 1,000 years. It's not the legacy you would have chosen, but it's the one you get, preservation through insignificance, survival through obscurity. The earth keeps better secrets when nobody's looking for them. The gold mask catches lamplight in a way that makes your eyes hurt. You're standing in a tomb chamber that's been carved out of bedrock somewhere in what will eventually be called the Mycenaean world, around 1300 BCE. The chamber is small but carefully finished, walls smoothed and plastered, floor level despite the slope of the hill above. In the centre, on a stone platform, lies someone important enough for a gold death mask, important enough for a tomb that required weeks of labour to prepare. You're here because you're one of the craftspeople responsible for finishing the tomb, not the main architect or the goldsmith who created the mask, but one of the workers who smoothed the walls, sealed the floor, installed the door mechanism, the technical labour that makes grand gestures possible. Tomorrow the tomb will be sealed permanently, the door blocked with stones and plastered over, the entrance concealed to prevent robbery. Tonight is your last chance to see the work complete. The deceased's personal effects are arranged around the platform: weapons, pottery, jewellery, a few items that suggest religious significance. Standard burial goods for someone of rank. What's not standard are the other objects in the chamber, tucked into corners and niches, things that weren't mentioned in the official funerary plan. Someone, probably several someones, has been adding items to the tomb without authorization. You notice a clay tablet with what looks like accounting records, a bronze tool that's clearly been used for leatherworking, a small statue that doesn't match the regional style. These aren't burial goods in the traditional sense. They're hiding. Someone is using this tomb as a secure storage location, counting on the fact that sealed tombs don't get opened unless loot has breached them. The impulse to add something of your own is sudden and hard to resist. You've got a small bronze chisel in your tool bag, the one you've been using for the detail work on the walls. It's a good chisel, well balanced, comfortable in your hand after months of use. But it's also potentially evidence that you were here, that you had access to elite spaces, that you possess skills which might be valuable or dangerous depending on who's asking. The political situation has been unstable lately. The kingdom is dealing with succession disputes and external pressure from groups the officials dismissively call sea peoples, though that phrase seems to encompass anyone arriving by boat looking for new places to settle. Instability creates opportunity but also risk. Skilled workers like you become valuable during construction booms and expendable during contractions. Your name is on employment records, tied to projects that might become politically problematic. Burying the chisel in this tomb would remove that evidence from circulation. It would also preserve a small piece of your working life, though that motivation feels secondary to the practical concern of making certain objects disappear. You wrap the chisel in a scrap of wool, then tuck it into a niche in the wall, behind the pottery that was officially placed there. Anyone opening the tomb would need to remove multiple items to reach your hidden addition. The concealment takes about 3 minutes. You're practiced at making yourself useful without being noticed, which is a survival skill for workers in royal contexts. When you leave the tomb chamber and help seal the door, you're confident that nobody saw you add an unauthorized burial good. The chisel will stay there, forgotten and invisible, until some future moment when the tomb gets opened. That moment comes about 3,000 years later, when archaeologists excavate the tomb as part of a systematic survey of Bronze Age burial practices. The opening of the sealed door is documented photographically, every step measured and recorded. The initial discovery of the gold mask creates immediate excitement. Intact elite burials are rare enough to be significant. Then comes the detailed cataloguing of grave goods, and confusion begins to set in. Why is there a tablet with accounting records in a burial context? Why does the tomb contain working tools alongside ceremonial objects? Why are some items clearly damaged or worn while others appear to be unused? The assemblage doesn't match expected patterns for elite burial. The excavators develop theories. Perhaps this tomb was reused, opened and refilled at a later date with mixed deposits from different periods. Perhaps the burial goods represent a cross-section of the deceased's life, including their administrative role and craft patronage. Perhaps there's some ritual significance to including damaged tools alongside pristine ceremonial items. Your bronze chisel gets catalogued as a burial good, analysed for metallurgical composition, compared to other bronze tools from the period. Someone writes a paper about craft production and elite patronage, using your hidden chisel as evidence that the tomb's occupant had direct connections to metalworking workshops. The paper's conclusions are entirely wrong, but they're published in a respectable journal and cited by other researchers. The misunderstanding is complete. Your act of concealment, hiding a tool to remove evidence of your access, becomes interpreted as reverent burial, as intentional inclusion in funerary assemblage. The tomb accidentally becomes a time capsule because multiple people used it as a hiding place, each concealing items for reasons that had nothing to do with honouring the deceased. The funny part, which you'll never know, is that the deceased probably wouldn't have minded. Elite tombs were always partially fiction, carefully staged presentations of status and power that may or may not have reflected the person's actual life. Adding random hidden objects just makes the fiction more complex without fundamentally changing it. The tomb was already a performance. You just added some unauthorized props. But that's the thing about burial contexts. They're supposed to be permanent and sealed, which makes them paradoxically attractive for temporary concealment. People hide things in tombs counting on the fact that disturbing the dead is taboo. They don't account for future generations who treat ancient tombs as historical artifacts rather than sacred spaces, who open sealed chambers in the name of knowledge rather than respect. Every systematically excavated tomb contains this tension. The original intention versus later interpretation, the planned assemblage versus accidental additions, the official narrative versus hidden realities. Archaeology catalogues everything with equal attention, which means your hastily concealed chisel gets the same scholarly treatment as the gold death mask that required months of skilled labour to create. Equal documentation doesn't mean equal understanding. The mask was meant to be seen and interpreted, designed to communicate specific messages about status and importance. Your chisel was meant to disappear, to exist in the space beyond interpretation. But burial equalizes everything. Underground, intention dissolves. Only the objects remain, waiting for someone to dig them up and assign new meanings that may or may not have anything to do with why they were placed there. You helped seal the tomb with the satisfaction of knowing your evidence was safely hidden. The irony that you actually ensured its preservation, that concealment in a sealed tomb is one of the best ways to guarantee an object survives for millennia, wouldn't have brought you comfort. You were thinking in terms of immediate safety, not long-term archaeological value. The tomb stands sealed for 3,000 years, holding multiple layers of concealment and intention, some planned and some accidental. When it finally opens, the archaeologists find exactly what they expected, an elite burial with all its associated complexity and ambiguity. They just don't realise that some of that complexity was people like you, using the space for purposes the architects never intended. Time capsules work best when they're accidents. Intentional preservation comes with explanatory notes and careful curation. But accidental time capsules, sealed spaces that accumulate unauthorized additions, that become hiding places as well as burial sites, those capture something more honest about how people actually interact with sacred spaces. They show the gap between official function and practical use, between intended purpose and opportunistic adaptation. Your chisel sits in a museum storage drawer now, labelled and catalogued, part of an assemblage that scholars still argue about. The debates will continue because the evidence is genuinely confusing, a mix of intentional burial and hidden concealment that doesn't resolve into a clean narrative. That confusion is the most accurate part. It's the only thing about the tomb that truly represents the complicated, improvised reality of the world that created it. The manuscript in your hands is incomplete, and you did that on purpose. You're sitting in a workshop in medieval Paris, probably around 1200 CE, though the exact year matters less than the fact that it's several decades after the Albigensian Crusade finished destroying most of the Cathar communities in southern France. The workshop belongs to a bookbinder who doesn't ask questions about the texts he's hired to copy and preserve, which is why you're here instead of somewhere more reputable. The manuscript is a copy of theological writings from the Cathar tradition, not the main texts, which are already too dangerous to preserve, but secondary materials, commentaries, and letters that explain practices and beliefs. You've spent 3 months producing this copy, working from memory and fragments of partially burned documents that you salvaged from a house in Toulouse. The original materials are gone, destroyed by crusaders or their local allies, condemned to deliberate forgetting by ecclesiastical authorities. Your copying wasn't exact. You changed names, removed references to specific locations, edited out passages that seemed most likely to trigger prosecution if the manuscript was discovered. You also added ambiguity in places where the original was clear, creating textual confusion that might protect readers from accusations of heresy. The result is a document that preserves some information about Cathar beliefs, while deliberately obscuring other details. This is selective memory on purpose, preserving enough to maintain continuity while concealing enough to provide protection. It's also exhausting. Every editing decision required judgment calls about danger versus accuracy, about what future readers might need to know versus what might get them killed. You've essentially decided which aspects of Cathar thought deserve to survive and which can be safely forgotten. The bookbinder is preparing a special binding for the manuscript, one with a false cover that makes it look like a standard prayer book. Inside that binding you'll add additional concealment, blank pages at the beginning and end, innocuous prayers copied onto the first few folios, anything that creates space between casual inspection and the actual content. The manuscript will be buried not in earth but in plain sight, hiding among legitimate religious texts in the library of someone sympathetic to the cause. Plain sight burial is riskier than physical concealment, but potentially more accessible. A manuscript buried underground might survive indefinitely, but it serves no purpose if nobody can read it. A manuscript hidden in a library might be discovered and destroyed, but it might also be read and copied, creating new chains of transmission. You're betting on circulation over preservation, on use over security. The decision isn't entirely rational. Part of you knows that the Cathar tradition is effectively finished, that no amount of manuscript preservation will resurrect communities that were physically destroyed, but giving up on preservation feels like accepting the Crusaders' victory, like agreeing that certain ideas deserve permanent erasure, so you're creating this incomplete, edited, concealed manuscript as a form of resistance that you know is probably futile. The funny thing about selective memory is that the selections themselves become historical artifacts. 700 years later, when scholars finally gain access to the manuscript you're creating tonight, they'll recognise immediately that it's been edited. The missing passages will be obvious from contextual clues and grammatical gaps. They'll write papers about what was removed and why, developing theories about the manuscript's transmission history. Some theories will be accurate. Scholars will correctly identify that you removed names and locations to protect people. They'll recognise the passages where you added deliberate ambiguity to create interpretive flexibility. The textual analysis will be sophisticated and mostly correct about your methods. What they'll miss is the emotional weight of those editing decisions, the specific anguish of choosing which theological concepts to preserve and which to let fade, the guilt of knowing you're creating an incomplete record that will shape how future generations understand Cathar beliefs, possibly forever. The lonely certainty that you're probably the last person who knows what the original texts actually said, making you simultaneously preserver and destroyer. You finish binding the manuscript into its false cover and step back to examine the work. It looks innocuous, exactly as intended. Someone casually examining it would see a well-made but unremarkable prayer book, the kind of text that wealthy households commission as displays of piety. The hidden content is invisible without careful reading, protected by the camouflage of orthodox religiosity. Tomorrow you'll deliver it to the library where it will begin its long concealment. The librarian who accepts it will ask no questions, file it carefully among similar volumes, and forget about its existence. The manuscript will sit undisturbed for centuries, gradually accumulating the physical characteristics of age. Brittle pages, faded ink, binding damage that will make later conservators nervous about handling it. Its content will survive not because of your preservation efforts, but despite them. Your careful editing and concealment will make the manuscript less interesting to potential destroyers, allowing it to hide effectively. But that same editing will frustrate later scholars who want access to the complete original texts. Your compromise between preservation and protection will satisfy nobody perfectly, which is maybe appropriate. Compromises rarely do. The selective memory you've created isn't false exactly. Everything in the manuscript is accurate as far as it goes, but it's incomplete in ways that matter, gaps that can't be filled because the sources no longer exist. You've created a deliberate amnesia, a structured forgetting that preserves some things by concealing others. Whether future readers will thank you or curse you for those choices is unknowable and probably irrelevant. You're not preserving for gratitude, you're preserving because the alternative, letting everything disappear without resistance, feels worse than creating an imperfect record. The manuscript might never be read by sympathetic audiences. It might be discovered by hostile authorities and destroyed anyway. But at least you tried. At least you didn't accept erasure without attempting preservation, however flawed. The concealment is complete. The manuscript exists in a state of simultaneous visibility and invisibility, physically present but intellectually hidden, available but not accessible, preserved but not complete. It's a perfect metaphor for selective memory, for the way communities try to maintain continuity through periods of violent suppression. You preserve what you can, conceal what you must, and hope that future circumstances will allow for more complete revelation. That revelation will never come, not really. The Cathar tradition will remain a subject of scholarly debate and historical speculation, known primarily through hostile sources and incomplete fragments, like your manuscript. The deliberate gaps you created will become permanent features of the historical record. Future understanding will be shaped by your editing choices, made in this workshop on a night when you felt overwhelmed by the responsibility of deciding what deserves to be remembered. But that's always how it works. Memory is selective not just because human brains have limits, but because preservation requires choices. What to save, what to risk, what to conceal, what to reveal. These decisions shape historical understanding more than most people realize. The past doesn't survive intact. It survives in edited form, shaped by individuals who made desperate compromises between accuracy and safety, between completeness and survival. Your manuscript represents one of those compromises. It's not heroic or particularly noble. It's just someone trying to preserve something while acknowledging that perfect preservation is impossible. The earth isn't the only way to bury secrets. Sometimes you hide them in books, protected by deliberate incompleteness and strategic ambiguity. The shovel hits something solid, and your heart sinks because you know what it means. You're standing in a construction site in what will eventually be called Beijing, in the year 1974, though you'd probably identify it as the 63rd year of something else, depending on which calendar system you were using. The construction site is supposed to become part of a water pump station, mundane infrastructure for a growing city. What it's become instead is the biggest archaeological complication of your career. You're not an archaeologist. You're a farmer who got recruited for construction labour because the work pays better than farming, and you're young enough to handle physical demands. Hitting solid objects underground should be routine. You found old foundations, bits of wall, scattered pottery and dozens of previous excavations. But this is different. The object you've hit is curved and smooth, and clearly not natural. More importantly, it's large in a way that suggests there are additional large objects nearby. You stop digging and call over the site supervisor, who has enough experience to recognise immediately that this is a problem. Within an hour, actual archaeologists arrive, bringing equipment and excitement and a bureaucratic energy that suggests your simple construction job just became complicated. By the end of the day, the site is shut down and converted into an official excavation. What you found, though you won't understand the significance for several weeks, is part of the Terracotta Army. Thousands of life-size clay soldiers buried alongside China's first emperor over 2,000 years ago. It's one of the most spectacular archaeological discoveries of the 20th century, and you found it by accident while trying to install water infrastructure. The excavation that follows is careful and systematic and takes years. Archaeologists document everything in meticulous detail, photographing each soldier's position, recording soil composition, analysing breakage patterns. You get to watch some of this, reassigned from construction to excavation support, moving dirt and helping set up equipment. The work is less profitable than construction, but more interesting, at least initially. What becomes clear as excavation progresses is that the army was buried deliberately, but discovered accidentally. The tomb complex was designed to remain hidden indefinitely, protected by earth and secrecy. The emperor's grave goods were meant to accompany him in death, not to be displayed in museums or photographed by tourists. The burial was concealment with no expectation of revelation. But time and political change undid those intentions. The dynasty that buried the emperor was overthrown relatively quickly. Records of the tomb's location were lost or deliberately suppressed. Centuries passed. The mound that marked the emperor's burial became just another hill, notable mainly for being artificial, but no longer connected in public memory to any specific burial. The terracotta soldiers underground became forgotten, their existence known only to soil and earthworms. Your accidental discovery transforms that concealment into exposure. Within months, the site becomes a major archaeological project. Within years, it's a tourist destination. The soldiers that were meant to remain forever buried are now among the most photographed artifacts in the world. The emperor's attempt at permanent concealment has been comprehensively defeated by a farmer installing water pumps. The irony would be funny if it weren't so complete. The emperor commanded resources that most ancient rulers couldn't imagine. Thousands of workers, years of labour, an entire industry of craftspeople producing clay soldiers. All that effort went toward creating a concealed tomb that would never be disturbed, and it worked, mostly. The tomb remained sealed and hidden for over 2 millennia, far longer than most ancient burials, but forever is longer than 2,000 years. Eventually someone expands a city, decides they need water infrastructure, digs in the wrong spot, and suddenly your secret is international news. The concealment that seemed permanent was just waiting for the right combination of technology and accident to breach it. Watching the excavation proceed, you start noticing details that the archaeologists find fascinating, but that strike you as sad. The soldiers were painted originally, but most of the paint flakes off almost immediately upon exposure to air. The preservation inside the sealed tomb was nearly perfect, but exposure to oxygen begins degradation within minutes. The archaeologists work frantically to document original paint colours before they fade, but they're racing against chemistry that they can't quite win. The soldiers were better preserved when buried. Discovery initiated destruction, or at least transformation. The very act of revealing them changed their nature from preserved artifacts to deteriorating objects requiring constant conservation. You've helped convert permanent concealment into permanent maintenance. The tourists who will eventually flood this site won't think about that trade-off. They'll see impressive ancient sculptures, marvel at the craftsmanship, take photos next to their favourite soldiers. The loss of paint and the ongoing conservation challenges will be invisible to casual viewers, mentioned maybe in small text on informational plaques that nobody reads carefully. The transformation from buried secret to public spectacle will seem like an obvious improvement. Of course, it's better for these artifacts to be seen and studied rather than remaining hidden underground. But you're not sure. The soldiers were doing fine underground. They didn't need to be found. The Emperor's concealment strategy was actually working. Your discovery didn't rescue them from obscurity. It interrupted a preservation technique that was successfully maintaining them for millennia. You've essentially destroyed a system that worked in order to implement one that requires constant intervention. The archaeologists don't talk about it this way. They're excited about the information revealed, about insights into Qin dynasty military organization and artistic practices. The discovery enables research that would be impossible if the soldiers remained buried. From that perspective, your accident was beneficial. It converted inaccessible information into available knowledge. But conversion costs something. The soldiers will never again experience the stable environment that preserved them so effectively. They'll be maintained, certainly, protected by modern conservation techniques and climate-controlled displays. But maintained is different from preserved. Maintained requires continuous effort, constant vigilance, technological infrastructure that might fail. Preserved just required being left alone. You're not an archaeologist or a philosopher, so these thoughts remain largely unvoiced. You go back to construction work once the excavation no longer needs manual labour. The site becomes a museum complex that you visit occasionally, seeing your accidental discovery transformed into tourist attraction. Each visit is strange, watching crowds of visitors photograph soldiers that you personally uncovered, seeing gift shops sell miniature replicas of artifacts that you held in your actual hands before the archaeologists arrived. The disconnect between the buried soldiers and the tourist attraction is complete. The objects remain physically the same clay, same faces, same swords, but their meaning has transformed entirely. They've gone from burial goods to museum pieces, from concealed secrets to public knowledge. The Emperor's intention to keep them hidden has been comprehensively overridden by historical accident, and that's ultimately what your discovery revealed. Not just clay soldiers, but the fragility of permanent concealment. No matter how much effort goes into hiding something, no matter how effective the concealment technique, eventually someone installs plumbing in the wrong spot, and suddenly your secret is displayed under museum lights. Time defeats all burial, given enough patience and accidental excavation. The Emperor probably wouldn't be happy about this outcome. He went to considerable trouble to ensure permanent concealment, using strategies that were sophisticated for their time. But he couldn't account for political collapse, for dynasties ending, for cities expanding over former burial grounds, for technologies he couldn't imagine being used by people who didn't care about his intentions. You destroyed his secret by accident, with a shovel and a water pump project. The elaborate concealment that took years to construct was breached in an afternoon by someone who had no idea what they were uncovering. And now those soldiers stand in climate-controlled halls, stared at by millions of tourists, their paint mostly gone and their purpose entirely transformed. The Earth kept the secret well. It was people who couldn't leave it alone, and so the buried things eventually surface, transformed by time and discovered by accident, their original purposes obscured by layers of soil and interpretation. The secrets that people carefully concealed, from religious persecution, political upheaval, personal grief, administrative convenience, become archaeological data, museum displays, scholarly debates. The act of burial preserves but also transforms, changing private meanings into public artifacts, turning desperate concealment into celebrated discovery. You've walked through different centuries, different motivations, different outcomes, but the pattern remains consistent. People bury things when they can't protect them openly, trusting the Earth's patience over human uncertainty. Sometimes the concealment works permanently. Sometimes it works until someone accidentally breaks through. Either way, the buried object exists in a suspended state between intention and discovery, waiting for someone to decide its fate through deliberate search or random excavation. The Earth doesn't judge these concealments. It just holds them, patient and indifferent, until the weight of time or the curiosity of strangers brings them back to light. And in that patient holding, sometimes things survive that never would have lasted in the open air of their own time. The paradox of burial, that hiding can preserve better than display, remains as true now as it was when people first thought to place valuable objects beneath their feet and trust soil over neighbours. The secrets are still there, in thousands of locations, waiting for their own accidental discoveries or remaining permanent in their concealment. Each one represents someone's calculation about danger and preservation, about what deserves to survive and what protective methods might work. The buried truths outnumber the discovered ones by orders of magnitude. Most secrets stay secret. We only hear about the ones that resurface, which creates a misleading impression about the success rate of concealment. But lying there in comfortable darkness, you can appreciate the elegance of Earth as archive. It doesn't require maintenance or passwords. It doesn't judge content or worry about relevance. It just accepts what it's given and holds it until someone decides to look. That's better than most security systems humans have invented. And it's been working since people first recognized that sometimes the best way to preserve something is to make it invisible for a while. or forever, depending on who's asking and what they're looking for.